Okay, I want to give an additional lecture on del operator. So this is the del operator. Okay, so okay, as you see, this is the del operator, and you see x, y, z means this one is for Cartesian. Okay, how will it be for cylindrical? What in the cylindrical? What is the that you have? This one. And this one, right? Okay. And how about the spherical? Spherical, you have r plus, you have also theta, okay, and you have this one inside and in phi, which is this is your spherical. Okay, so in cylindrical coordinate we have dr, okay, and also we have r d phi, and also z, there is nothing different, it's just dz. Here I think you guys know, right? This is rd phi is actually when we do the cylindrical, okay, and then let's say we have phi here, okay, then what is this length? Okay, the length cannot be in angle, so this one is actually r d phi. Okay, so I hope you guys still remember. And then for the spherical, the spherical is that it is dr and r d theta and r sine theta d phi. Okay, d phi. Okay, so how can you know about this one? Okay, this one I think you guys have learned in the class how to have this value, right? How to have this combination. So rearranging this, then you have d, dr, r. Okay, you can put at the front also have so I think it's okay. And then you have 1 over r d theta, okay, and it's in the theta direction. And also you have this, sorry, then you have d phi. Okay, so in the phi direction. Okay, you can put this one at the front if you want. Okay, you see this one, plus d dy plus z d dz. Okay, the same goes for the others, for cylindrical and spherical. Okay, now let we see for the exercise. Okay, for the exercise regarding using of the del operator. Okay, as I provide in the supplementary material, see, the gradient of a scalar v written as del v, the divergence of vector a written as del dot a, the curl of a vector a written as del cross a, and the Laplacian of a scalar v written as del square v. Okay, so we use this del operator to in combination with the other vectors, and we must solve according to the coordinates. Okay, so to simplify your solving, you need to solve it using the correct coordinate. Sorry for the sound interruption just now. Okay, now for example, okay, let we see for this question, determine the gradient of the following scalar field. Okay, so for this question, okay, this one, determine the gradient of the following scalar field for A. The gradient of the following scalar field. So okay, so go back to the definition. The gradient, what is the gradient of the scalar field? Okay, this is the gradient of scalar field, scalar V, written as del V, and this is the definition. The gradient of scalar V is a vector that represents both the magnitude and the direction of the maximum space rate of increase of V. So you see that V is your scalar field. So when you want, you can read this later on. That's why it's important to have the book. Okay, and for this question, you can see it is x, y, z. So it is a Cartesian coordinates. So you solve it using this. Okay, so what we can do is that take the question first, x squared y plus x, y, and z, okay, which is u. Okay, now we want to know the gradient of it. Okay, how is the gradient of it? Okay, so the gradient of it is actually you have del, okay, u, okay, and remember, and you have this one, right? You have this one. This one is d dx x plus y d dy plus z d dz. Okay, so each of these you multiply with this, okay, with this u. So okay, for example this one dx, okay, you differentiate this one, okay, this first in x, don't forget the x, okay, so differentiate of this, what you get 2xy, am I correct? And then you differentiate this one with respect to x, then you have yz, okay, then plus y, this one you differentiate again, this one, then you have x2 power of 2, am I correct? And then y, you have zx plus this dz, okay, you differentiate this. Of course the first one is 0, okay, because there's nothing of z here, and plus the differentiate again this one, then you have x, y, okay, and then rearranging, or to make it simplify, okay, you see there is y here, right? Y here, you take the y, then you have 2x plus z, and x direction of x, plus, how about this one? You can factorize the x, then you have x plus z. Am I correct? Then you have y plus this one is 0. So it's just x, y, and z. Okay? You can try this. Okay? You can try this one. The other example or practice exercise 3.2. Okay? Add z sine phi z square cos square phi r. Okay? So I don't want you to confuse. Okay? This is just a radius, okay? The radius of the cylinder, okay? The radius. Sometimes we use r, sometimes we use rho. It's the same. It's just referring to the same radius, okay? To the, meaning the same, which is radius. So you solve this. You can try to solve this using cylindrical, and you can try to solve this using spherical, okay? And this is the answer, okay? This is the answer. If you guys have problem, okay, we can discuss it later on. Thank you.